let's work with this case, which is the design intent of a rectangle, but applied in such a way that we get a square. Okay? So this is our sketch. Now, if we close the sketch and we go ahead and hit the extrude command, we've started to make our first solid. Let's give it 75. Let's have something that is not that well defined. And let's give it a value of 75. Okay? I end with this sketch and I click the extrude command. Same name, right? Same name for the extrude command. Hit 75, hit the check mark. Oh, yeah. Uh, it doesn't automatically select the sketch for me, but and there you go. We close the sketch. Now, freecad doesn't call it extrude, it calls it pad. That's probably the only difference. Everything else is about the same. Okay, so there we go. Hello and welcome to this first video in this new series. Now, in this video, we will be talking about design intent, what it is and how you can apply it. And we'll also make an example solid with the simplest of commands, which is the extrude command. But first, a few words on this new series. Now, in this new series, we'll be talking about design strategies that can be applied across parametric CAD systems, right? It's aimed mostly at beginners, but it's not going to be click this, click that type of tutorial to get a specific shape. It's going to be laying the foundations of parametric CAD use. So you can then take that to any other CAD system and start your professional career or apply to your hobby or whatever. The format of this series is going to be that I will be explaining the above mentioned strategies in alibre Design Expert, and then we will be taking the same methodologies, same tools, same workflows to other CAD systems and seeing how they behave and what results we get. Now, let's get to our design system. This is alibre Design Expert, and let's start by saying that in parametric CAD systems, the most common workflow, not the only one, but the most common one, is you create a sketch and then you use it in one of these features to create a solid. And by repeating that process with successive sketches and features, you build the solid geometry that you want to build. And also sketches, at least 2D sketches, we have 3D sketches, that's for later on. 2D sketches can be applied to planes or flat faces. Now, when you start a 3D, when you start a 2D sketch, the main tools are the sketch tools, which are lines, rectangles, arcs, and so on, and the constraints. Now, constraints are geometric rules, right, that can be applied between two sketch entities. For example, we have the perpendicular constraint. If you apply that to lines, they will always be perpendicular, right? They will be able to float in space, for example, but they will do so while being perpendicular. Another one is tangent. You know, a line to a circle can be tangent to arc segments, parallel, and so on. Okay, so sketch tools to draw something, geometric constraints to define its shape and its relationship to other sketch entities in space. So let's start by trying to make a square, right? In parametric CAD, it is generally advisable to start designing as far away from the actual shape that you want to achieve, and then constrain it and dimension it so that you get what you need. Once you build up experience, you can start with something that's closer to your final desired result. But this is a good rule of thumb as you're still learning. So let's say that we want to make a square. Okay, So let's think, what are the defining characteristics of a square? Well, it has 4 lines. There they are. We have them. Those lines are perpendicular to each other, right? And they are also equal to each other. That is what a square is. So let's start creating those geometric definitions, right? Perpendicular. Let's make these 2 lines perpendicular. They move, they're now perpendicular, and we get a little icon here showing us that. Perpendicular, and this is perpendicular. Now, geometric theory tells us that we don't need to apply this last one, because if these 3 are perpendicular and the ends are common, this will also be perpendicular. And sure enough, when I try to apply it, I get an error saying that it results in an over-constrained sketch, right? It's telling me that it didn't apply that particular constraint because it doesn't need it, right? It is over-constrained. Now, the other thing that makes a square is that all of the lines are equal. But because we also have all of the lines being perpendicular to each other, if we make 2 of them equal, the other ones will be equal by definition. And again, sure enough, when I try and apply this constraint, it will result in an error telling me it's not necessary. Okay? So now I have a square. But if you really look at it, I don't have a square. I've got any square. Okay? In order to get something more specific, I need to dimension one of these edges. Okay, let's make that 15. So it changed color. In alibre, red, it means that the magnitude, length, angle, whatever, and the position is not defined. Orange means that the magnitudes are defined, but the position is not. Okay, so how is this position undefined? Well, if I click and hold and then drag, you can see that it moves in a circle, right? So what I have defined here is this. Any 50 by 50 square that has one corner common to the origin of the coordinate system. So this is what I have geometrically defined here, right? So while the magnitudes and the shape is defined, it's not certain where that is in the plane. That is why the position is undefined. So let's say I want to have this line of the square be horizontal. Well, we go to the horizontal constraint. Again, horizontal, another geometric definition. Now, this square can only be one thing, right? This is a 50 by 50 square that has one point common to the origin, and the line that starts from that point horizontal. So now we can start talking about design intent. Okay, so the design intent of this shape is a square, starts from the origin and has the first line horizontal, right? That is the design intent. And then this particular shape is the one that fulfills that design intent and happens to be 50 by 50 millimeters. Okay. Now, let's say that we wanted to design a rectangle that starts from the origin and has its first line horizontal. Well, the only difference between a rectangle and a square is that not every line is equal, but they're equal in pairs, right? So if I delete that equal constraint, you can see now that the only way I can drag it is by dragging one line to create a rectangle, okay? So let's make this rectangle 50 by 100. Again, fully defined. Now, let's go over it again. Design intent. The design intent here is that of a rectangle that starts at the origin and has its first line horizontal. That is the design intent. But what is this particular shape? This particular shape is a rectangle that starts at the origin, has its first line horizontal. This is the design intent portion, and happens to be 50 by 100 millimeters. Okay? Now, take a look at this. Let's make this 50 millimeters. Okay? Now, let's go over it again. The design intent here is that of a rectangle that starts at the origin, has its first line horizontal. Which rectangle, you might ask? Well, that one that has a 50 millimeter height and a 50 millimeter length. You see, this is a square basically, but a square is a subcategory of rectangles. So even though we have the design intent of a rectangle, the shape is actually a square. So this is something that you need to pay attention to. And one final example, this equation, this dimension is called D1, and this dimension is called D2. If I make the value of this dimension be D1, now it is always going to be equal to this one. So if I change this, they both change at the same time. Now, I have reverted my design intent by doing this, by linking the two dimensions, okay? Making them equal. I have reverted my design intent back to that of a square. It's just a different way of doing it, but it's the same design intent as if I had made these two lines or these two equal, right? Okay. So let's not make them equal. Let's make this 50 millimeters, and let's have this be 25 millimeters. Okay? No, actually, you know what? Let's uh, let's work with this case, which is the design intent of a rectangle, but applied in such a way that we get a square. Okay? So this is our sketch. Now, if we close the sketch and we go ahead and hit the extrude command, we've started to make our first solid. We will explain the extrude command at length on our next video, and what design intent we can have here. For now, let's just say that the way the extrude command creates a solid is by scanning it in space and giving it a height. Okay? Uh, so let's give this a value of 25. No, not 25, because that makes a cube, right? Let's give it 75. Let's have something that is not that well defined. Okay? So now we have a shape which uh, is in the geometric category of polyhedrons, and I believe it's called parallelepiped. I'm not sure of the pronunciation in English, but I'll let you guess the language these words are borrowed from. It's basically six faces. Two of them are equal, and the other four are equal between them. So this is again, this is a group that contains the cube. Okay, but let's take what we just talked about and apply them to other CAD systems. Let's start with Fusion 360. Okay, so we start a square. We start with a sketch on the XY plane. We take a line. Uh, your toolbars are not going to be like that. I've hotkeyed the line, so I took it out of here. I wanted more room up there. Okay, so let's start with a line. We do the same things. Oh, we missed. Okay. So we've done the same thing. We can drag, and these 4 points are completely arbitrary at the moment. Let's start making them perpendicular. And let's see, what if we do the... Okay, so we now have a message saying it's over constrained. You can see it's the exact same wording that we got from the error message in alibre. Okay, let's start making these equal. Okay, now we've got this square flying around in a circle, right? And also changing size. So let's give it a value. So the value we're going to give it is 50. And now we're going in the same circle we were going in alibre, and let's make it horizontal. In Fusion, horizontal and vertical is the same constraint, and it kind of tries to understand what you want to do. Not much of a difference. Again, we have the same thing. This is a square. The design intent is that of a square, and the shape is a square 50 by 50. How do we change the design intent to make it a rectangle? Well, we delete the equal constraint. Okay, same behavior. We give it a value of 100. This is the rectangle. This is the rectangle that has a dimension of 50 by 100. And if we go back to 50 here, okay, the design intent is a rectangle, starts at the origin, first line is horizontal, and dimensions of 50 by 50. Okay, so again, design intent of a rectangle, shape of a square. Let's make this 25 by 25 to match what we did in alibre. We finish the sketch, and we go for the extrude command. Again, I took it out of here. Yours is going to be a button up here. I took it out of here because I hotkeyed it. And let's give it a value of 75. Okay? So, same workflow, same commands. We got the same error message, and we ended up with the same shape. Okay? Now let's try with another CAD system, onshape, right? So, sketch. I start with this plane. Okay? Small differences. It doesn't spin it vertically by default. Okay. I grab a line, start at the origin, roughly the same shapes. By the way, I also want to see the constraints. It doesn't show it automatically. Then I take the perpendicular constraint. Again, same name, right? It's three different software, and it's also called a constraint, and it also has the same name. Okay. And if I try and constrain the last two, oh, it's given me it. It's allowed me to do it. Probably it deleted some other. Oh, I know what happened. I missed the first. It didn't click on the first. Okay. Well, in any case, you can clearly see that when I try and apply that last perpendicular constraint, it just doesn't do it. Okay, it doesn't give me an error message. It just doesn't do it. Exactly because it is over constrained. So click and drag. Right. This is what we have. You click and drag. Same thing as the other die. Let's make these two equal. Same workflow. Now it's a square. Okay. Let's make this 50 millimeters. And now you'll get the square going around in a circle. Okay. And now let's make this horizontal, and it's fully defined. Okay. How do I turn the design intent to that of a rectangle? I just delete the equal constraint. Now if I click and drag, that's all I can do. Let's make that 100. So we're going through the same steps, okay? And let's go back to 25 by 25. Now, again, the design intent here is that of a rectangle, right? The design intent here is that of a rectangle that starts at the origin, has its first line horizontal, and happens to have dimensions 25 by 25. So the shape is a square, but the design intent is that of a rectangle. I end with this sketch, and I click the extrude command. Same name, right? Same name for the extrude command. Hit 75, hit the check mark. Oh, yeah. It doesn't automatically select the sketch for me, but and there you go. Third different CAD system. Okay, you probably can tell that I'm not very comfortable with onshape, only be using it for a couple of days. So, third CAD system, the same workflow, choosing the same sketch tools, same name, same constraints with the same name, and we got the same results. Okay, and finally, freecad. Okay, the thing with freecad is that it's not one CAD system; it's many different CAD systems. But the parametric design workbench in CAD is the part design workbench. So we need to create a body first so that we do stuff to it. And then we create a sketch. FreeCAD has this tasks toolbar that pops up and helps us guide us a bit. You can either click create sketch from here or, the icon up here. Select the XY plane and we grab a line and we start doing our thing. Okay, no. I need to make sure that the point lights up. And as the point lights up, you see a little icon that pops up. That's the incident constraint. That makes these 2 points be the same point. This was applied in every other CAD system we used, but it was applied without the system telling us. They were there. Okay, so we made our shape. Now let's start making it perpendicular. There you go. There you go. Third one. Now, if we go for the fourth one, what happens? Nothing happened. Why not? I have auto remove redundants selected, right? FreeCAD also has that. If I try and spin it around, you see what I get. Okay, let's make it now a square. Well, make these two equal, and now it's a square. Okay. Let's make this line be 50 millimeters. And let's do the circular dance we did in every other CAD system. Excellent. And now we'll make this line horizontal. And now we're fully defined. How do we change the design intent to that of a rectangle? We select the equal constraint and we delete it. Okay. And if we drag, the universal way of testing in parametric CAD, we get rectangles going on. Okay, so let's go through the same motions. Let's do this. 25, make this also 25. And what do we have here? Again, the design intent is that of a rectangle that starts at the origin. The first line is horizontal, okay, and happens to be 25 by 25 millimeters. So this is, the shape is a square, but the design intent is that of a rectangle. So we close the sketch. Now, FreeCAD doesn't call it extrude, it calls it pad. That's probably the only difference. Everything else is about the same. Okay, so there we go. And this is it. So, fourth different CAD system, same workflows, same names for the tools, and we got the same results. Okay, so I hope you liked it. I hope you learned something. If you have any questions about the design intent, what is it, how you can apply it, please leave a comment. I'd love to answer any questions. And if you liked it, click like. If you didn't like it, click dislike. And if you want to see more, hit subscribe. And I'll see you in the next one.